Write an algebraic expression to represent each situation. Let C represent the number of coins. In problem 6, it says 8 less than twice the number of coins. For twice the number of coins, we would do 2C, and 8 less than that, we would subtract 8. You are just writing an expression, so it does not need an equal sign, and make sure you're using C as your variable to represent the coins. Use the graph to complete the ratio table and the double number line. It says the number of quarters is 6. In the table or in the graph, if you go to 6 for the number of quarters, you can see that the height of the stack is 10.5 millimeters. You can see that one coin, or 1 quarter, is 1.75. In ratio tables, we can look for patterns. 6 times 2 is 12, so 10 times 2 would help us fill in this, or 10.5 times 2 will help us fill in this box. 10 times 2 is 20, and a half times 2 is 1, so this would be 21. I notice that 10.5 times 3 would give us 31.5. So 6 times 3 will help us fill in this box. For the number of quarters here, if 1 is 1.75, then 10 would be 17.5. We would multiply by 10. For 10 to 20, you're multiplying by 2, so we can multiply by 2 here as well. 17.5 times 2. 2 times 5 is 10. 2 times 7 is 14, plus 1 more makes 15. 2 times 1 is 2, plus 1 more makes 3. You've got that 1 decimal spot here, so you need 1 decimal spot there. And in a double number line, it also uses the same scale. So we go 10, 20, this one should say 30. Tyler collects cans and takes them to a recycling center. He exchanges the cans for money. Tyler receives 2 cents per can. Complete the table. So he has 1 can. If he gets 2 cents per can, that would be 2/100ths of a dollar. If he has 2 cans, we would multiply that by 2 to give him 4 cents. 3 cans times 2 cents would be 6 cents. 4 cans at a rate of 2 cents per can is 8 cents. And 5 cans for 2 cents is 10 cents. Let C represent the number of cans Tyler collects. Use C to write an expression that represents the total amount of money Tyler receives. We are taking the number of cans and multiplying by 0.02. So we can write that as 0.02 C, where C represents the cans. This is just an expression, so it does not need an equal sign. For these next few problems, instead of using 0.02 to represent the dollars he earns, we're going to use 2 to talk about how many cents he earns, and P is going to represent how much money he makes from the cans. So it says, consider the situation in problem 2. For problems 3A through D, use the equation P equals 2C, where C represents the number of cans Tyler collects. Let P represent the total amount of money in cents he receives. So we are going to solve for P when C is 30. So we're replacing the C with the number 30. Remember, we wouldn't just write a 30 next to it because then it looks like 230. We want to use parentheses or a dot to indicate that there's multiplication happening between the number 2 and the variable C. Well, P is a variable and 2 and 30 are both numbers, so they're already on the correct side. 2 times 30 is 60. So he would earn 60 cents. Here it says find C if P is 30. So in our equation, we're replacing the P with 30. Remember, to solve, we have to undo what's happening to the variable. So right now it's being multiplied by 2. We can undo that by dividing by 2. 30 divided by 2 is 15. So he has to find or collect 15 cans to earn 30 cents. The next one says, what is the total amount of money in cents he receives if he collects 120 cans? Well, the cans is the C. So we're replacing the C in the equation with the number 120. 2 times 120 is 240 cents. How many cans does he collect if the total amount of money he earns or receives is 120 cents? P is the cents, so we're putting 120 in the P's position, and we need to solve it for C. To undo what's happening to the C, we have to divide by 2. That leaves us with C, and 120 divided by 2 is 60. So he needs to collect 60 cans. Consider the stack of quarters situation in problem 1. We know that 1 quarter had a height of 1.75 millimeters. So if we have 3 quarters, we need to multiply by 3. 5 times 3 is 15. 3 times 7 is 21, plus 1 more makes 22. 3 times 1 is 3, plus 2 more makes 5. We should have 2 decimal spots, so this would say 5.25 millimeters. For the next one, we are multiplying 6 quarters by a height of 1.75. 6 times 5 is 30. 6 times 7 is 42, plus 3 more makes 45. 6 times 1 is 6, plus 4 more makes 10, with 2 decimal spots. We can keep this going. That would be 26.25. Part B, write a ratio that relates the height of the stack in millimeters to the number of quarters. What is the value of that ratio? So it mentioned the height first, which was 1.75. Remember, a ratio can get the 2 dots for the colon, and then the number of quarters was 1. The value of that ratio is when we write it as a fraction and divide. So the value of the ratio is 1.75. Part C says let Q represent the number of quarters. Use Q to write an expression that represents the height of the stack. So remember, we were multiplying the quarters, or the number of quarters, by 1.75. So you can write 1.75 Q. Let H represent the height of the stack in millimeters. Now write an equation that represents the ratio relationship between the height of the stack in millimeters and the number of quarters. So with the equation, we use the equal sign. E, use the equation to determine the height of the stack of 8 quarters. So we are replacing the Q for quarters with 8. So we're multiplying 1.75 by 8. That would be 40. 7 times 8 is 56, plus 4 more makes 60. 8 times 1 is 8, plus 6 more makes 14, with 2 decimal spots. 14 millimeters tall. Use the equation we wrote in part D to determine the number of quarters if the height was 40.25. The height was represented by H, so we're replacing the H with 40.25. And we need to solve it for Q, the number of quarters. 1.75 is being multiplied by Q, so to undo that, we need to divide, and do so on both sides to keep our equation balanced. Any number divided by itself is just 1, so we have 1Q. And then 40.25 divided by 1.75 is 23. So it will take 23 quarters to reach a height of 40.25 millimeters. For parts A through C, identify the independent variable and dependent variable in each situation. Justify your reasoning. The independent variable, in this case, is x. And the dependent variable is y. Y is dependent on x because it's being multiplied by 0.3. So based on whatever x is, we'll have to calculate the y value. The value of y depends on the value of x. So in this one, the independent variable would be n, and the dependent variable would be r. The value of r depends on the value of n. We would put a value in for n and then multiply by 1/3 to find what the value of r is. In part C, the independent variable would be a, and the dependent variable would be b. B's value depends on what we put in for a. You can kind of just write the same little sentence, replacing the letters in each one to match part B and C. For parts A through C, identify the independent variable and the dependent variable in each situation and justify your reasoning. The value of P is 6 times the value of Q. So Q is the independent and P is the dependent. P's value depends on Q. Scott earns $9 per hour. Let H represent the number of hours Scott works, and let M represent the total amount of money in dollars he earns. So H is the independent variable, and M is the dependent variable. The amount of money he earns depends on how much time he works. C. Tara walks 1 mile in 15 minutes. Let D represent the distance Tara walks in miles, and T represent the amount of time Tara walks in minutes. T is the independent, and D is the dependent. The distance she walks depends on the time she spends walking. Sana makes bracelets by using chains and beads. She needs 5 beads for every inch of chain she uses. Let C represent the length of the chain in inches Sana uses to make one bracelet, and let B represent the number of beads Sana needs. C is the independent variable, and B is the dependent variable. The number of beads needed depends on how long the chain is. A lemonade recipe calls for 3 tablespoons of lemon juice for every 1 cup of water. So 3 tablespoons for every cup of water. Here we have the number of tablespoons of lemon juice and the number of cups of water. She needs 3 tablespoons for every 1 cup of water. So then the next one could say 6 tablespoons for 2 cups of water, 9 tablespoons for 3 cups of water, or 12 tablespoons for 4 cups of water. The way that we are getting these answers is we're taking the tablespoons of lemon juice and dividing by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. 9 divided by 3 is 3. And 12 divided by 3 is 4. It says in part B, let J represent the number of tablespoons of juice, and use J to write an expression that tells us the total cups of water. So we're taking the juice, J, and we're dividing by 3 every time. C, let W represent the cups of water. Write an equation that represents the relationship between the number of cups of water and the number of tablespoons of lemon juice. Use W and the expression you wrote in B. So we have the water is the juice divided by 3. And the water, so we're identifying the independent and dependent variable. The water depends on how much juice you have. So the water is the dependent, and the juice is the independent variable. The amount of water depends on how much juice we have. Complete the table. This time we're starting with the cups of water. So if we have 1 cup of water, we would need 3 tablespoons of juice. If we have 2 cups of water, we need 6 tablespoons of juice. With 3 cups of water, we need 9 tablespoons of juice. And with 4 cups of water, we need 12 tablespoons of juice. So this time, to get from 4 to 12, we're multiplying by 3. 3 times 3 gives us 9. 2 times 3 gives us 6. And 1 times 3 gives us 3. Use W to write an expression that represents the number of tablespoons of lemon juice based on the water. We're taking the water amount and multiplying by 3. You could also write this as 3W. F says to write an equation that represents the ratio relationship. The juice is equal to 3 times the water. Identify the independent and dependent variable in this case. The juice depends on the water this time. We started with the water, and the juice depended on how much water we had. Mr. Evans orders pizzas for the class. Each pizza feeds 4 students. Complete the ratio table. So we have 4 students, and they need 1 pizza. If I had 8 students, they would need 2 pizzas. 12 students would need 3 pizzas. And 16 students would need 4 pizzas. Define variables to represent the quantities in this situation. This would be, let's go with students and pizzas. Identify the independent variable and dependent variable. We need to write 2 equations that represent these relationships. So if we start with the students, we need to divide by 4 to get the pizzas. 8 divided by 4 is 2. 12 divided by 4 is 3. 16 divided by 4 is 4. But if we start with the pizza side and go this way, we take the pizzas and we multiply by 4 to get the number of students. In this case, S is the independent and P is the dependent. But in this problem, P would be the independent and S would be the dependent. That's the end of lesson 22. Make sure to check back for future lessons and fill in your workbook.